Okay, so now I want to know, is g differentiable at x equals 1? Okay, and so this is the same thing as asking, does g prime of 1, which is equal to the limit as x approaches 1, of g of x minus g of 1 all over x minus 1 exist? Okay. So how are we going to determine that? Well, we need to consider the left-handed limit and the right-handed limit, right? Because at x equals 1, I switch functions. I have, when x is less than 1, I have the negative 2x squared plus 4, and when x is greater than or equal to 1, I have x squared plus 1. And so we need to consider the left-hand and right-handed limits. So I have that the limit as x approaches 1 from the left, g of x minus g of 1 all over x minus 1. That's equal to, I'm going to use the function that's highlighted in orange, right? Because to the left of 1, my function is defined for negative 2x squared plus 4. And so here, I'm going to say that this is the limit as x approaches 1 from the left of negative 2x squared plus 4 minus, now I'm trying to figure out g of 1, so I need to plug in 1 into my function. And then this is all over x minus 1. Okay, so over here I'll just note okay, so g of 1 is equal to that, which in this case is equal to 2 for the left-hand limit. Okay, so here what I get is I get that this is equal to the limit as x approaches 1 from the left of negative 2x squared plus 4 minus 2. So I'm just simplifying what's inside of those parentheses here. I just simplified this. And so this is over x minus 1, which is equal to the limit as x approaches 1 from the left of negative 2x squared plus 2. So I just added together the 4 and the minus 2. Simplifying, combining like terms in the numerator over x minus 1. And so this is the part here where I try to, now that I just like combined like terms and I sort of cleaned up my expression, I try to figure out, what is this limit? And so this is the part here where you try to plug in 1. And when I plug in 1, though, I get 0 over 0. Right? Because when I plug in 1 here, I get negative 2 times 1 squared, which is negative 2, plus 2. So I get 0 in the numerator, and then I get 1 minus 1, which is 0. And so now I need to try to figure out what can I do. I have a couple of techniques for 0 over 0. There's 5 different techniques, right? And so when we saw a polynomial over a polynomial, so we saw a rational expression like this, we had factoring, right, as like our main go-to, because we had factoring, multiplying by the conjugate. That was typically with roots, doesn't have to be though. But our first go-to when we see something like this, a polynomial divided by a polynomial, was to factor. And so if you notice in the numerator, we have, we can factor out a negative 2 in the numerator, because they both have a 2. And there's a reason I'm saying to factor out a negative 2, which you'll see in a second here. If I factor out a negative 2, I get x squared minus 1 over x minus 1. And so now the reason why I factored out that negative is now I have a difference of squares. See how I have x squared minus 1? This gives me a difference of squares. So here, this is going to be equal to the limit as x approaches 1 from the left of negative 2 times x minus 1 times x plus 1 all over x minus 1. So now I cancel these. And so this is the limit as x approaches 1 from the left of negative 2 times x plus 1. And so now I want to plug in 1. So I get negative 2 times 1 plus 1, which is equal to negative 2 times 2, which is equal to negative 4. Okay. So this was just the limit as x approaches 1 from the left. Now I need to do the same thing, but from 1 from the right, of g of x minus g of 1 all over x minus 1. But now I'm changing my function, right? When x is approaching 1 from the right, or in other words, when x is greater than or equal to 1, I use the function x squared plus 1. And so here, I'm going to say that this is the limit as x approaches 1 from the right, x squared plus 1 minus, I need to plug in 1 into that function, all over x minus 1. And so when I simplify this, I get this is the limit as x approaches 1 from the right of x squared plus 1 minus 2 all over x minus 1, which gives me the limit as x approaches 1 from the right of x squared minus 1 over x minus 1. So all I did here was I simplified what was inside of this brackets, and then I combined the 1 and the minus 2. So now, trying to figure out this limit, I get 0 over 0 again when I plug in 0. And so now I'm going to factor. So I get that this is the limit as x approaches 1 from the right, x plus 1 times x minus 1 over x minus 1. These x minus 1's cancel, and so I get that this is equal to the limit as x approaches 1 from the right of x plus 1, which is equal to 1 plus 1, which is equal to 2. Okay, so that was a lot of work here, but our final answers here I'm going to just highlight to you in pink. Alright, so I got the left-handed limit was equal to negative 4, but the right-handed limit was equal to 2. And so we note that the answer here is no. The limit does not exist. Since left-hand limit didn't equal the right-hand limit. And so f prime of 1 is, g prime. In other words, g is not differentiable at x equals 1.